Okay, to sketch the graph of this derivative, we're going to split it into two parts. Okay, from negative infinity all the way out to 2 on the x-axis, the original function is the graph of a line. To the right of 2, out to infinity on the x-axis, the graph of the function is a parabola. Okay, we know that the graph of a line is a horizontal line through the slope of that line. So the first thing we're going to do is we're going to put in a slope triangle on that line. So I'm going to go right here, up, and then over. So we have an up and down change of 2, and we have a left and right change of 2. So that is a positive line. 2 over 2 gives us a slope of positive 1. So we know that the graph of the derivative of this line is a horizontal line through positive 1. So we're going to put that in right here. Now, what's happening right here on the graph of the function at 2? This is a cusp. Remember, we can't take the derivative at a cusp because we can't draw in one distinct tangent line there. We can put in infinitely many different kinds of tangent lines. So whenever there is a cusp at that x value on the graph of the derivative, there has to be a hole there. So I'm going to put in a hole right here, and then our horizontal line through 1 goes to there. So our graph is increasing, which means our derivative is up here above the x-axis. And again, the derivative of a line, any line, is a horizontal line through the slope of that line. It's a constant because this slope is constant all along the line. Okay, now let's look at the other part of our original function, the parabola part. This is degree 2. So we know that the derivative is going to be degree 1. Every time we take the derivative, the degree goes down by 1. So degree 1 is going to be a line. So the derivative of any parabola will be a line. We need 2 points to sketch in a line. So the first point we're going to get is the easy one. Right here. Remember, whenever there's a max or a min, the tangent line will always be horizontal there. So we know that the slope is 0. So at positive 3, the slope of the tangent line is 0, which means there's an x-intercept right here. So that's our first point for our line. The second point, you pick any x value over here. Okay, I'm just going to pick x is equal to 7, which is right here. Okay, so I'm going to make a point. My x value that I'm picking is 7. And I want to find the derivative at 7, which is the slope of the tangent line. So I'm going to go over to 7 on the x-axis. I'm going to go up to the graph right here, and I'm going to draw in a tangent line right here. Now, I don't have a straight edge with my iPad, so I'm just going to wing it. So there's about my tangent line, okay? And I'm just going to put in a slope triangle. Okay, so I'm just going to pick this point here because that seems pretty easy. And I'm going to go down here, and then I'm going to go over. Okay, so my slope there, it is positive. I've got an up and down change of 4. I have a left and right change of 1. So 4 over 1 gives me a slope of positive 4. Okay, so down here from my point, at 7, the slope of the tangent line is 4. That means that this right here is a point on the derivative graph. Okay, so we're going to go up and we're going to plot that point over 7 and up 4, which is actually right there. So there is the point on my derivative graph. That actually worked out pretty slick. That won't always happen, that your point is, right on the function. All right, so now I'm going to sketch in the line. Again, I don't have a straight edge. So I'm going to connect this point to my first point, and I'm going to continue on down. Now remember, I only go to 2 on the x-axis because that's where this parabola starts, and I have to have a hole there. All right, I can have no y values on my derivative graph at the x value of 2 because there's a cusp there. and then I can continue it on up here. So there is the graph of this parabola's derivative. Let's check the relationships. All right, our minimum is here. That gave us this x-intercept. We are decreasing right here. So the graph of my derivative is below the x-axis there. And then from right here, my function is increasing. So then the graph of the derivative from that x value on is above the x-axis. All right, so there you have it. The graph of a line is a horizontal line through the slope of that line. If there's a cusp, there has to be a discontinuity, all holes there. And the graph of a parabola is a line. All right, hopefully that helps.